E equals mc squared. It's the most well-known equation in the world, developed by Albert Einstein and his groundbreaking work in physics. But what does it really mean? Why is it so significant? We are going to unpack this equation simply and plainly and provide to you a clear understanding of what it means and why it's such an important equation. It describes the relationship between mass and energy and comes from Einstein's theory of relativity. Before Einstein developed his equation, people thought of mass and energy as two completely separate things. Mass was the stuff that makes up objects, and energy was something that could act on objects like heat or motion. Einstein's equation changed our entire understanding of the universe by showing that mass can be transformed into energy and energy into mass. In other words, mass and energy are not different. They're two forms of the same thing. Einstein was surprised by his discovery, calling it amusing and enticing. The equation itself is quite simple. E stands for energy, m stands for mass. C squared refers to the speed of light squared. The equation tells us that energy and mass are directly related. They are two sides of the same coin. It states that the amount of energy an object has is equal to its mass multiplied by the speed of light squared. The speed of light is a huge number, traveling at 186,282 miles per second, or about 300,000 kilometers. So, a small amount of mass can be converted into a tremendous amount of energy. This is why nuclear power plants and atomic bombs produce such vast amounts of energy from relatively small amounts of fuel. Let's break down how the math works in E equals mc squared for a 5-pound mass and plug the values into the equation. E equals energy, the number we want to find. M is 2.268 kilograms or 5 pounds, the mass of the object. C equals 299,792,458 meters per second, the speed of light. The equation is quite simple. The amount of energy in a 5-pound object, if it were completely converted into energy, is equal to its mass multiplied by the speed of light squared. The answer is a mind-boggling number. The amount of energy equals 2.038 to the power of 17 joules, or 203,800,000,000,000 joules.
I agree.
Joules is the measure of energy, just as feet or meters is for distance. But what does this number really mean? How much energy is 2.038 to the power of 17 joules? To put it into perspective, it's enough energy to power the entire United States for several days. In reality, we can't completely convert 100% of a mass into energy, except in very specific circumstances like matter-antimatter annihilation. Nuclear reactions convert only a tiny fraction of the mass into energy. It shows the incredible amount of energy locked within even small amounts of matter. This is why nuclear reactions are so powerful, and why Einstein's equation has had such a profound impact on our understanding of the universe and human civilization. It unlocks the power of the atom and our understanding of nuclear energy. There are 3 main types of nuclear reactions: nuclear fission, nuclear fusion, and radioactive decay. Nuclear fission is the splitting of atoms, which is the nuclear process a nuclear power plant and a nuclear bomb uses. When atoms are split, some of their mass is converted into a very large amount of energy. Fusion is the combining of atoms, where a small amount of mass is converted into a tremendous amount of energy, as predicted by E equals mc squared. Nuclear fusion releases 4 times more energy per kilogram of fuel compared to nuclear fission. In terms of radiation, nuclear fusion releases significantly less, producing almost no long-lived radioactive waste, while fission generates unstable nuclei with much longer radioactive half-lives, making fusion a considerably cleaner energy source. The equation is also crucial in our understanding as to how stars work. In our sun's core, nuclear fusion reactions take place, where hydrogen atoms fuse together to form helium, releasing massive amounts of energy in the process. Fusion is where 2 atomic nuclei, hydrogen in this case, combine to form a single heavier nucleus, helium. It releases a significant amount of energy. This nuclear reaction is what provides light and heat to our planet and our entire solar system. Without it, life on Earth wouldn't be possible. The equation is also a key part of the broader principle of the conservation of energy. It tells us that energy can't be created or destroyed, it can only be transformed. If an object loses mass, that mass doesn't just disappear, it's converted into energy, which maintains the total balance in the universe. Beyond nuclear power, E equals MC² has had a significant impact in various fields of technology, from medical treatments like radiation therapy and X-rays, to the development of particle accelerators that allow scientists to explore the fundamental building blocks of the universe. Particle physics is another example of where this little equation impacts the human condition. When scientists smash particles together at high speeds in particle accelerators, they sometimes create new, heavier particles. E equals MC² tells us that the energy of the collision can be converted into the mass of these new particles. Einstein's equation is not just important because it explains nuclear energy or why the sun shines. It represents a deeper understanding of how the universe works. It reveals a profound truth that mass and energy are the same thing, they are interchangeable. The equation is crucial to space travel and the future of our civilization. If we ever want to travel to distant stars, we'll need incredibly efficient ways to propel spacecraft. The equation suggests that converting even a small amount of matter into energy could provide a tremendous amount of thrust. But it's more than just a formula. It's key to understanding the nature of reality itself. Its impact is seen in hundreds of thousands of ways throughout science and physics, and has opened the door to deeper questions about the fabric of space-time. E equals MC² has also captured the public imagination, becoming a symbol of scientific genius and the power of the human mind to unlock the secrets of the universe. It reminds us that the universe is full of hidden potential, and even the most seemingly mundane objects contain unimaginable energy within them. From nuclear power to our understanding of the stars, Einstein's little equation continues to inspire and challenge humankind. It reminds us of the awesome power and beauty of the universe we inhabit, and gives humanity and all of civilization the ability to grow and develop even further. We hope this has helped in your understanding of the world around you, and we look forward to seeing you in our next episode.